Question is, car A moves in a straight line while car B moves along a curve having a radius of curvature of 200. So how would you solve this problem? The car B moves along a curved line and the radius of curvature, if I tell you this is the radius of curvature, (200 meters). So VA is given, this is given, VB is also given. VB is how much? 30. And if I take this my I unit vector and J unit vector as a frame of reference, the question is, acceleration A is also given and acceleration B. So you have to find out velocity, relative velocity and relative acceleration. So do you remember that the formula for VB from A is VB vector minus VA vector, and the magnitude formula is the ith component square and jth component square, and the theta. Let's go slowly to find out the answer. So I want your help. What is VA vector? If this is along the vertical line, what is the vectorial component? Jth component only. So only the jth component is present, correct? So I will say 0I plus 40j. You agree with your professor? And how about VB? Can you find out the ith component and the jth component of VB? So if you take a look here, if I draw it here like VB and draw the reference axis here, this is my I unit vector, negative I. This is theta. So let's do one thing. If you, this is 60 by the way, this is 30, 60, 30. So if you do the math here, so what is this side equals to? This is either, so I can write down negative, make sure it is negative because on the left hand side of the origin. So what is this equals to? So VB equals to 30. So can I write down 30 sine 30? You agree with me? And this side, this is along the y-axis. This is J unit vector, correct? What is this side of this vector? You will see it is positive 30 cosine 30. Either you take 30 degree or 60 degree, it would be the same answer. And if you solve for this, you should get the answer. Let me solve for the final velocity, relative velocity, VB vector, so I can show you this would be the answer. And I will leave this to you. How is it equal to this one? It's just the math. You just have to calculate, multiply the numbers. So how about the magnitude formula? (20.5), and the angle, it is in the third quadrant, negative 15 and negative 14, correct? So this is my vector. Theta equals to tangent inverse negative 15, actually it should be negative 14 in the numerator, negative 15 in the denominator. You get theta equals to 43.1 degrees. So this is the first answer. Have you understood up until here? Okay, let's find out the second answer. Let me grab this picture again and solve this question for you. So the acceleration A is 4 meters per second. Acceleration, I would say acceleration A sub A is 4 meters per second squared. Acceleration A sub B, so acceleration A sub B equals to -3. So we want to find out acceleration B from A. So one thing I want to mention, this is B, acceleration B is -3 is the tangential acceleration. Okay, this is the direction of the, okay. You need to use the normal and tangential coordinates for the curved path. If the rho is 200, this is somewhere here, this is the normal unit vector, this is the tangential unit vector. So AB sub t is -3, so AB sub t is -3. So I want you to tell me, if you draw a, oh sorry, this is rectangle, I wanted to show you. Okay, let's draw a rectangle. Can you resolve this along the I and j component? If this angle is 30, so if this angle is 30, so you can do the math here. So let me write down AB sub t, the ith component plus the jth component. So you will see that this is the jth component of B. So can I write down? Let me rewrite here. -3, negative sign, -3 sine 30. Agreed? And over here, this is also positive. Okay, this is positive. I would say this is positive. -3 cosine 30. And what is this equals? Look over here, this is along the y-th axis. So this vector is along the j-th axis. Do you understand? I have resolved the tangential component of the acceleration into I and j components, because my major objective is use this formula. Subtract the ith from ith components, jth from jth components. First you do the math. First you resolve this into rectangular components. Now a n is not given directly, a b n, but you can find out. Do you know the normal acceleration formula? And what is v square? So v sub b you can find out from the from this data. So can I write down v sub b as 30 square over 200? Agreed? So is it 4.5? Can you make sure it is 4.5? I have to stop for a moment. He wants to talk to you.